So the next guy up is a security geek and a retired IT consultant who accidentally acquired his CISSP at the tender age of 22. If it processes data, he's probably tried to make it do bad things. He teaches, mentors, and explores, and occasionally explodes technology. Bobby Kuzma.
Okay, so we're actually working and groovy on this. Quick show of hands. Who's adequately caffeinated or otherwise chemically stimulated this morning? Okay, who works in a DevOps shop? Who actually does DevOps? Okay, this talk is not for you. So, there's a bit of a road here. We're going to be misusing and abusing DevOps tools to build lab and training environments. So your cyber range. Who went to the earlier talk on building an inexpensive cyber range today? Okay, so some of those ideas, totally different viewpoint on this, because there's scale and budget behind building this stuff. We're not talking about doing any of this stuff in production where we actually care about, maintainability necessarily or stuff actually staying up. And this talk was not approved by marketing or any other responsible adult, so the opinions are mine and mine alone, okay? Don't blame the people who write my paycheck. This stuff works for me. It may not work for you. And if you break other stuff by trying to do some of these things, don't blame me. Shoot me an email, I might try and help you, but don't blame me. So, hi, I'm Bobby. I'm a hacker. Yeah. So, most fun pen test and hacking stories start with some variant of, so there I was. And, when we do capture the flags, most often we're getting some kind of puzzle challenge. There's some reverse engineering, there's some packet analysis, there's some other weird aspect that not everyone deals with every day, so you've actually got to go and push the envelope a bit. Right? We're all familiar with this type of capture the flag. Yeah. That's not the kind of capture the flag I build. So I can't be blamed for starting down this path. We had an ISSA chapter out in California, the Ventura County ISSA chapter, and they pride themselves on being the training chapter. So every month they do some kind of hands-on training exercise. They don't do the suits, cocktail mixers, that kind of thing. They actually do hands-on, let's get some skills built up routines. And they idly asked, hey, Bobby, do you have something that we could do a red team versus blue team competition on? I'm like, no, but I could probably build one. Famous last words. So, we wanted to do something that's a little bit interesting. So we had a full enterprise network. We actually had it here last year and ran it after Delta destroyed the hardware. And that actually is what inspired automating out the build process as much as possible. So this thing had all the stuff you'd expect in an enterprise network, okay, for you to break. Actual live, we could have transacted business if we were stupid enough to do it in there. So, you had firewalls and had web servers, had AD, God help us, had a phone system that actually was live, Exchange, full Exchange implementation. It could actually send and receive email to the outside world. Also, God help us. There are files and workstations and all that stuff. And then I threw an EMR in there because healthcare environment, why not? And we've got some challenges when we're actually standing up an entire functioning network rather than something where we're doing piecemeal simulation or we're just presenting limited aspects of it for the benefit of the participants. And if you're not careful, those challenges will bite you. The same challenges you have in production all of the time. So one of our big problems is after one of these events, the network kind of looked like that. You know, there was a lot of splash damage because not everyone had a lot of finesse. And, you know, with time constraints and the fact that we're not actually running any kind of defensive infrastructure, it kind of encourages that big hammer approach, which tends to cause breakage. So you might be thinking, okay, Bobby, well, why don't you just use snapshots? You know, just roll the sucker back. Well, that doesn't work so good when you're not like continuously doing these operations. If things go stale, stuff breaks. You know, you get bit rot. You know, what happens when you restore a set of virtual machines that are domain joined after a while? Yeah, it's not happy for anyone. And God forbid that it's also got an Exchange server in it, because those really don't like being losing their domain trust relationships, because, you know, Microsoft. So, you know, we start thinking, someone's got to have solved this before, right? And, you know, we've got these parameters we're operating under, and we need to be able to build these machines or at least keep them going. So, started looking, and these DevOps guys have a lot of tooling that for building things over and over again without actually necessarily having a human do it, and then configuring them and deploying them. Like, that's actually something useful. I can work with this, right? Yeah, I should be able to work with it. So we start at the beginning. In order to deploy virtual machines, you have to have a base image, right? How do you get the base image? Well, you can have Jimmy the intern go and build them by hand, you know, these fine artisanal products. And then when he misses step 312 out of 742, and it doesn't work, you have him do it again, and again, and again, until he learns his lesson. Or, you know, goes and joins the accounting team or something. So, fun question. How many times can you reinstall Windows before you go stark raving mad? Like full-on nervous breakdown kind of thing. Okay, so we've got someone saying 1. That's a good answer. We were dealing with multiple flavors of Windows here. So in my case, it was about 50. Yeah. So, you know, there were some problems with this approach. Now, we found some tools to help make this go faster, right? Because SSDs are wonderful. Especially those PCI Express data center SSDs that Intel makes. Because if you're going to be doing this thing repeatedly, and good God, if any of you have coworkers who do like script Windows deployments or any of that stuff, and they're working with all those funky Microsoft XML files to do the auto unattend stuff, that's literally a guess, check, and revise process. You don't really snapshot that and then roll it back and then tweak it. You start from scratch again. So we make this go faster, right? And I managed to kill 2 different 2 terabyte Intel data center SSDs while we were, you know, getting this kind of squared away. It takes a lot to kill those things. Like hundreds of petabytes of writes. Well, when we're doing like 400 builds a day, that does that. It's a problem. So we're back to square one with the drinking. And we've got this concept that the DevOps guys have stolen. It's this whole immutability thing. We want the base to be unchanging, right? Because we want to know what we're building on. We want that firm foundation. We don't want to have variability at that point in the process. You know, kind of like our friend here, who did poorly in the box office the last weekend. So we've got this glorious tool called Packer. Who's heard of Packer? Awesome. So those of you who had your hands up, please turn to those of you who did not have your hands up afterward and extol the virtues of Packer. Because Packer lets us build VM images across multiple hypervisors from a single set of configurations. So we can actually throw this onto like into a Jenkins process and just do daily builds of the OSs when it's all said and done. And we can do it for multiple platforms. Okay? So you've got devs that do their stuff in one particular hypervisor, but production's a totally different hypervisor. And we want the devs to have the same stuff that you're throwing in production so that they can, you know, do the testing and not have their test environment also be production, right? Because everyone has a test environment. Just some of us are lucky enough that it isn't production. Anyway, Packer uses these JSON-based config files. So, you know, they're relatively easy to interpret and understand, and you know, it's divided up into a couple of different parts. One that's hypervisor-specific, because there's hypervisor-specific stuff going on there. You don't want to inject VMware tools into something that's going to be living on VirtualBox and vice versa, or Zen, or AWS, or whatever. So we can also have this thing go out and grab the ISO automatically. So we don't have to rely on it being in the location where we're at. So imagine being able to build an entire Windows network without ever having to manually download an ISO. And it takes care of validating that the ISO didn't get jacked up by your crappy hotel internet connection because you're rebuilding this damn thing at 2 in the morning before an event. So we got our builders. The provisioners are common. They run across all the things. You can copy files into the VMs. We can do scripts. In the case of Windows, because Windows, you can't do anything without having 43 different reboots during the cycle, you know, unlike an actual operating system. You know, all of that can be done and done repeatably. This is cool. Then when we're done with that, we can do all kinds of things with the output here. We can go ahead and gzip those suckers up so we can throw them up on a repository somewhere. We can package them up into virtual appliance formats. We can import them into our ESX infrastructure. We can package them up as boxes for Vagrant. And I'll get to Vagrant in a little bit here. But the key is, all of those steps that we were doing by hand in this lovely artisanal process, we can get somewhat automated, which is a good thing, as they say. You know, you figure it must be hard. It's complex commands, right? Yeah, packer build, and then point it at the config file. Boom, done. Then it spits out some output. You don't even have to look at the thing. Seriously. You can run it headless without a GUI. It goes faster. It's delightful. So, when we're talking in the Windows universe, interesting thing, a lot of the Windows stuff that we need downstream, for security reasons, Microsoft doesn't let you actually execute those installers remotely. You have to drop a batch file onto the system ahead of time to execute it as part of the boot process in order to get them to do things like, install PowerShell properly on and configure it on a Server 2008 R2 instance. I know, old operating system, but we're building a capture the flag. We want people to be able to pop stuff. So, of course, and it's not like I never, ever encounter a Server 2003 box or an NT4 box or a 25-year-old Xerox print server that's running some kind of weird operating system. Never encounter anything that old in real life, right? We only encounter new shiny. So, we've got our base images. Okay, cool. So this is our canvas to work with. So let's say that you don't have that big rack of boxes for running this on. You just want to run something locally, okay? Or you want to experiment with how you're going to deploy something before you code it up in an actual config management tool. You just want to get it done. So Vagrant is the delightful tool that helps us with that. Okay, Vagrant was designed to answer the problem for developers of, hey, it works on my machine, because, DLL hell or library incompatibility, and, it became this arduous ordeal with setting up a dev environment for the new guy, because God only knows what all went into the current dev environment. So how do we throw that into source control? Okay, so we have a little script. We abstract out all the virtualization setup. So the networking, the VM configurations, the underlying VM images, and then what scripts we're running on those to actually set them up. It's lovely. There's a huge library of pre-built Vagrant boxes out there. Not so much on Windows, but you can build your own. And Packer can spit out Vagrant boxes, which makes life a little bit easier. Vagrant's built on top of Ruby. You have to do a little bit of Ruby-ish syntax to make this thing go. Okay, fine. I don't like Ruby personally. It's just makes my brain hurt, and I'm getting old and decrepit and kind of senile, so I don't necessarily enjoy doing Vagrant configs, but they're really simple. And then all you have to do to actually run them is type Vagrant up. That's it. It goes, grabs the boxes that you need. It goes, applies those provisioning scripts. And then you've got virtual machines sitting there running. And they can have all kinds of interesting internal network topologies. So you can do multiple machines at once. So if you're testing a client-server thing, or you're playing with the client-server thing, guess what? Okay, here's your client, here's your server. Have fun. I wouldn't do a big network with it, but it works. So that's my daughter Zoe, and I don't let her run persistent servers on our household VM infrastructure, and she likes Minecraft. So she gets to stand up her Minecraft server when she wants to play Minecraft. And we use Vagrant for that. So if a 6-year-old can figure out how to do that, I think that most InfoSec professionals and IT professionals should be able to work their way around it, but it varies. Now, we get a little bit further along. We want to actually put this onto infrastructure because we want to scale this. We want it not just to exist on your laptop or your desktop. Okay? So this problem's been solved too. We know that just writing these scripts for deploying things by hand kind of sucks. And there's multitudes of reasons why that's a bad thing. Because your scripts always end up looking like this because, it only takes 5 lines of code to actually script something most times, and then it's 5,000 lines of exception handling. Because you always hit that edge case, or you get a partial deploy and you didn't remember to start from scratch, so now you have to track state and all kinds of fun things like that. Or, it looks kind of like the classic IKEA assembly instructions. So the DevOps guys went and stole a word that comes into play with the configuration management tools. It's idempotency. And this is a property, they steal it from some math bits, but essentially, if we define out what something is to look like, then a tool can take from here, and we need to go over here, and getting through that process is the tool's problem, not yours. So there's some maturity going on there. And you end up with, okay, so this is what we want it to look like when we're done. This is the F1 engine from the venerable Saturn V. Okay, how do we get from raw materials to that? Well, that's something else's problem. We just have to define what it looks like at the end. Something else has to do all the actual engineer and build steps. So we've got a couple of different config management tools out there. The most popular are Puppet, Chef, Ansible, and Salt. Puppet and Chef, great tools. They're built on top of Ruby. Limited brain space, don't want to have to deal with that or a domain-specific language in there. Ansible and Salt, built on top of Python. I can understand Python. Now, with these config management tools, you have options for agent-based config management tools, which you can bake that agent in using Packer, or agent-less config management tools. Now, we're building this as a capture the flag that people are going to hack on. Do I really want to leave an extraneous extra bit of software there that someone can screw with? That is one philosophy there. I didn't particularly care to do that thing. So Puppet and Chef and Salt all have support for an agentless deployment model, but Ansible's agentless only. So that's what I ended up using to build this sucker out. Now, this is an example of an Ansible playbook. And in this case, we're going and taking and actually provisioning out a virtual machine from a given template and configuring out all of the bits and pieces. And come holler at me afterward, and I'll give me a card, and I'll shoot you over the slide deck, because the lighting's kind of screwy in here. But we can define this out. It's the syntax. It's YAML, yet another markup language, because we have to keep defining brand new ways to represent semi-structured data, and because can't use JSON, can't use XML, we have to have a totally different way of doing this, right? We can configure things. So Windows boxes, okay, we want to install those features, stuff that you'd normally just run a bunch of PowerShell commands against. And the beautiful thing here is if I rerun this playbook on a system, it's not going to try and reinstall that. It's going to look at the state of the system and go, oh, okay, so you already have this, this, and this installed. And now we get to do these other things. Or if your minion has gone onto a system and it's not behaving properly now, we could use those tools to force the correct configuration back onto the system and unjack up those fun and delightful things. So, Ansible, you run it on top of Linux. In this capture the flag environment set, we actually build an Ansible server as part of our base build process, and then fire off a second phase on top of that. But it just goes through the individual tasks, identifies what it needs to change, lets you know what it changed, and then gives you a good to go, not good to go, that kind of routine. It's useful. So let's talk real world. Okay? We had 20 different target VMs in this thing, and 5 infrastructure VMs. So there was management network, a scoreboard, a couple of monitoring pieces. We started doing these things and supporting 30 players. The last event that I did last year, we had 120 in the environment. And that did involve freighting a very large Pelican rack full of equipment to the site. But the build process for this thing was about 1,300 steps. And when I was doing it by hand, I basically spent a work week in front of the keyboard executing this. It's not a fun way to spend a week. And it took longer because there were processes that didn't require me that just execute and off you go. So we're looking at it taking a solid week-ish, if we were lucky, plus an actual work week to build this. Now, does that sound like fun to anyone? Yeah. Yeah, it was very delightful. So we built out Packer elements, started from some publicly shared configs, and customized them from there. So we were building out both CentOS and Ubuntu images, your desktop operating systems, a couple of flavors of those, a couple of flavors of Windows, and on my laptop, which is a 1.5-year-old Lenovo, takes about an hour to build all of the base images. That's not too bad. And that's assuming a reasonably fast internet connection to pull them down, if I haven't already pulled down the ISOs. So, okay, so we're seeing that's like a third of the time that I was spending in front of this thing. We've compressed it down to an hour. I think that we could all agree that that's probably a useful thing. Then we kick off to Ansible, and it deploys the VMs. We actually build the domain via scripting, throws software on all of the boxes, because I'd prefer not to. This is a philosophical contention point. I prefer to start from absolutely virgin base images without preloading any software into them. Some people prefer to preload common software elements into those VMs. I want the flexibility downstream to be able to just put whatever I need on them without having to have a second VM for that. Then we build out users, and that takes 2.5 hours on the depending on the hardware. And we've gone from single, like little Supermicro Xeon D boxes, 128 gig of RAM, 8 cores, all the way up to a half rack or a quarter rack worth of HP DL360 servers that are maxed out. It's oddly consistent in terms of the build and configuration time. And that leads to some interesting elements, because one of those hallmarks with the DevOps process is we want it to be consistent and repeatable, which means the same. So what happens when you've got someone who shows up at more than one of these events? They have a leg up, right? So you want to build in variability, which goes completely against the normal DevOps concepts. And they look at the DevOps types look at you funny when you go, well, I want to randomly select things in here. I want to pull from a list of passwords and inject them, or I want to randomly change what servers are being deployed and where they're deployed in there. They don't like that. So Ansible's delightful because you can build a quickie module that'll let you add in that randomization. Oh, and assuming I haven't screwed with it, this was a constant iterative process, and typically there would be a couple of changes between deployments. And of course, those require troubleshooting, because that's just our luck. The demo gods are always vengeful. So we do this thing. It's 2 Git repos. We've got one for building the base images, and then we've got the one that gets installed on the Ansible box and then executed. It's designed for fairly quick turnaround. At points last year, I was doing 2 or 3 of these events a week in different cities. Okay? September of last year, I did 4 events in 3 countries in 7 days with complete rebuilds between each event with travel time. So that's a degree of both reproducibility and automation that has some use cases. Depending on what your goals are for building an environment like this. Is it for identifying promising candidates for your shop, turn them loose in a lab for a bit and see what they can do? I've had some folks suggest, okay, so this is a hideously unsecure network. We're looking at you for our vulnerability remediation team. Well, you've got 3 hours. Lock this thing down. See how well they do. And when it's done, blow it away. Or the classic pen testing routine. We start with a hideously vulnerable network, and then if people start getting, shall we say, cocky, there's always some extra run books that can be run against everything that'll tighten things up. It's probably not nice to do, but I did on one occasion apply some STIGs to the boxes in the environment mid-event just to slow them down. Well, no one ever accused me of necessarily being fair. I want to create a good gaming experience, and clearly we had some really, really sharp people, so let's match it to their skill level. And I didn't STIG everything, okay? I just STIG'd like a third of the boxes. And some of them I didn't completely apply the STIG. I know. I'm a little bit evil. Just a little. Just a little. So by the end of the weekend, I'm going to have both the image build script set and the actual generate the whole environment up on those GitHub repos. So I've got to do one more pass to make sure I've pulled out all of my good and sensitive bits, like config passwords and things like that. But yeah, by Monday those should be up for you to grab and clone and play with. And if you want to explore doing that, feel free to reach out. Does everyone who wants a picture of that have a picture of that yet? I still see a couple of phones up. Okay, that's delightful. And then, shoot me an email, hit me on Twitter, whatever. The people who pay my bills, keep an eye on them, all that fun stuff. So, we've got a little bit of time left. Want to give you some of that back, but do we have any questions that anyone wants to drop? Otherwise, I can mute this thing and, you can wander up and ask in semi-relative privacy. Yeah? Awesome. Well, thank you very much for coming on out. Hope you enjoyed the con, and we'll catch you next time around.